Hello and good morning, good afternoon, or good evening, depending on where you are. Thank you for joining us today. My name is Nisha, and I'm a product marketing manager here at AppViewX. Our topic for this webinar is Drive Network Automation and Microservices Applications, which is presented by Glenn Gray, a senior solutions architect at AppViewX. To give you some background on our company, AppViewX creates intuitive software that enables NetOps, SecOps, and DevOps teams to orchestrate, automate, and manage network infrastructure, security, and application delivery. Our customers include several Fortune 500 companies that use the platform at scale. We are headquartered in Seattle and have a presence in 7 locations across the globe. Just a little housekeeping before we begin. If you have any questions, please type them into the Zoom control panel at any time, and I will bring them up during the Q&A session at the end of the presentation. So let's dive right into the webinar. Over to you, Glenn.
Yes, thank you, Vijna. My name is Glenn Gray, Solutions Architect with AppViewX. And for today's agenda, I wanted to cover monolithic versus microservices architecture, some of the primary changes of applications as it relate to microservices, microservice architecture and the network, ways to overcome challenges, and how the AppViewX platform can help. Then we'll end with a brief demonstration. So, monolithic versus microservices architectures. With the introduction of microservices, sometimes there's a challenge in understanding what the major differences are between a monolithic style application structure versus microservice style architecture or structure to applications. When we look at monolithic structures, you have application, business logic, which are tightly packed together. You have functionality for application instances that are bundled within perhaps a single host, tightly coupled, where database tier, web tier, they're communicating and passing data internally with really a direct coupling. The nature of the communication is very tightly bound together. So your traffic flows are typically static. If you have separate database, web tier, and even processing logic, maybe mid-tier, the data flow between each of those is very static in nature, where the session establishes from the client perspective at the web tier and then cascades down to maybe mid-tier logic and then down into database structure. And it's very linear in its orientation. Changes at any layer require pretty much that the entire infrastructure be reconfigured or taken offline in order to add new updates, changes to logic, improvements to the application. Whereas microservice architectures, you have your components broken down into modular components where they're loosely coupled, providing the ability to simply establish sessions to the individual logic component of a microservice. And that would allow extreme flexibility. You could take application instances or service instances offline, quickly introduce new service capabilities, new feature sets, direct only segments of the traffic to those instances, So it's highly distributed and very agile in nature. Primary drivers for application microservices, mentioned a few already: the hyperscalability, the rapid development and delivery opportunities that are offered, the flexibility, the distributed ownership, where you'll have maybe database administrators dedicated to a particular application product, and yet others associated with separate database application structures. And it also helps with failure isolation and that fault tolerance. You can quite easily expand the service instances for the microservice component, and when individual service instances of a microservice application instance fail, they're easily redirected to available instances. So the microservices architecture and the network. So with all of these smaller, highly agile, loosely coupled application instances acting in a microservice fashion, how does that apply to the network itself? And how is the network going to adapt to the evolution of and proliferation of microservices? Well, application services would become to interact with the network infrastructure in more of an on-demand basis as the deployment and proliferation of the microservice instances are applied. In addition, there's a change in the application traffic patterns that introduce more of an east to west bound orientation as opposed to north-south, meaning from provider edge down into the lower tiers of, say, database service offerings, where in a monolithic structure, you have the orientation of provider edge into a web service tier, again down cascading perhaps into mid-tier logic and database structures, and all of the traffic predominantly traverses in this north-south bound orientation. Whereas with the microservices, you'll have each service instance that is collectively offering application level business services interacting, and that traffic flow pattern becomes more of an east-west bound, where you'll have connections from the service provider edge, maybe terminating on your web tier, but then communicating laterally over for authentication, again, communicating laterally over for authorization, and the list goes on from that point as far as the service offerings that are collectively providing the application service. So this distribution, this high distribution of service instances introduces a need for load balance services. It introduces the high use of things like DNS and authentication services as well, and the ability to rapidly deploy security policy and not only build, but remove as you actively maintain the needs for microservices as they expand and contract. So how do we keep up with this rapid development, rapid deployment type model? Centralized services, the ability to discover and dynamically detect on an application-centric basis where your services are active and where they've been deployed. So being able to detect in a dynamic fashion the actual traffic pattern path for application-centric views across your infrastructure, which firewall policies are being associated with this application instance, which load balance, which pool members, which certificate instances for encrypted traffic systems, which IP address allocations, and even which items under your ITSM are being created to keep track of the configuration items that are being created and removed. Centralized monitoring, so being able to detect state and status from this application-centric view, and a centralized failover policy that would facilitate for deploying redundant services and extending self-service capabilities for application administrators to invoke traffic failover, traffic redirect, so that they can maintain application patching, deployment, upgrades, and the like. And then tools to automatically deliver the network services that are required, like the load balance deployment structures, the firewall security policy deployments, the DNS address reservations, IP address reservations. So how does AppViewX help? Primarily as a low-code NetOps or DevSecOps orchestration platform, combining together the visibility of your network infrastructure and a workflow orchestration engine to allow you to do adds, modification, deletion of configuration items throughout your hybrid, multi-cloud, multi-vendor environment. It offers the discovery of your network infrastructure and presents it in an application-centric viewing perspective, and allows you to manage the infrastructure that, again, is multi-vendor, hybrid as well. And for configuration and deployment of applications, the microservice application instances, it offers the flexibility of the orchestration and workflow design engine. We can also leverage configuration management solutions, tools like Ansible, Chef, Puppet, Terraform. We can integrate with those platforms as well to enhance the configuration management capabilities with contextually aware services. And lastly, the application-centric topological view, which I've mentioned a couple of times about the application-centric visibility into dynamically discovering the path that application traffic takes throughout your infrastructure. So being able to stitch together from the fully qualified domain name down through the security policy structure through the association to certificates and into the load balanced infrastructure to virtual servers, pools, and pool members, and identifying not only the devices where the traffic would flow, but the state and status and the ability to interact with those platforms for troubleshooting functions, identifying with the security policy the number of hits that a particular service policy has accrued at that point, the number of active connections, the ability to ping, trace, route. So a lot of standard routine troubleshooting techniques within the application-centric view. So the approach for automation with AppViewX, which we've prescribed, is beginning with the discovery, meaning taking the infrastructure, integrating it with the AppViewX platform so that it can discover from the device inventory, from the device infrastructure, all of this application-centric information, and then progressing to a management phase where you're identifying the commonalities or individual inherent modalities, if you will, of each application instance. And then third, the design of automation techniques to apply highly repeatable deployment strategies for not only creating new applications, but maintaining them and deleting them. All of those leading ultimately to a full lifecycle automation and orchestration capacity. So lastly, the feature set here that we're really trying to point out is achieving one-touch network orchestration where you've discovered, you've been able to manage the infrastructure and define highly repeatable workflow techniques so that you can easily provide application services to your business and spin up and spin down microservice instances at high volume. And this would work over multi-vendor, multi-environment, meaning hybrid, cloud and on-prem infrastructures, and also be context aware, configuration aware, meaning that the nuance of your particular business needs are taken in consideration with the customization of the workflow strategies. It's provided within a visual workflow palette so that it is a drag and drop design process and very intuitive. And what results are the reusable workflow structures. And all of this is extended in a granular role-based access control so that individual teams can self-service and initiate requests, track the process, and even roll back, modify the workflow instances as they're either in flight or post-completion. So this slide just sort of visually summarizes how the AppViewX platform can integrate with hybrid data center, cloud, on-prem service environments with multiple vendors and covering various services within the ecosystem: application domain control, firewall and security, DHCP, DNS, IPAM, certificate vaulting, certificate authority instances, and even ITSM for service management, as well as extending capabilities to interact, manage, centrally view the entire IT infrastructure by individual stakeholders and technology skill sets like DevOps, like SecOps, NetOps, even application developers and engineer support members. So with that, let me jump over to a demo environment just to try to further illustrate some of the features that I've been describing. So I'm going to log into an application instance within a demonstration environment where we have several items under management, which would include application domain controllers, web services, firewall security endpoints. And I'd like to describe a bit about the request or workflow studio. So in the slides, I was attempting to describe the proliferation of microservices and how the AppViewX platform can help to enable the deployment and support lifecycle management of microservice application instances. So starting off, I wanted to describe how requests are viewed from an end perspective. And I'm going to look at a previously completed request, which was referred to as a zero-touch provisioning for an application instance. And hopefully what this will identify for you is how workflows can be constructed so that the contiguous application deployment might be supported for your environment. So as I look at a previously completed request for a zero-touch provisioning instance, bear with me while I'm trying to scroll here. There it goes, caught up with it finally. So if I look at a previously completed deployment for a zero-touch provision application instance, this instance was deploying a virtual service instance, and it was integrating with the ServiceNow platform. So not only configuring a virtual server pool member instances, but recording the information or the configuration item tracking within the ITSM platform of ServiceNow. So in this case, it had been initiated from ServiceNow in the form of a request item. So we can integrate with a north-southbound orientation to external user interfaces. So if you're wanting to drive your consumers towards a service catalog instance that's already established in a ticketing system such as ServiceNow, it can be extended and simply through the REST API of the AppViewX service listener. All of these workflows could be initiated outside of the web user interface of AppViewX. So in this case, it had been generated And the form collection, which we see here for the virtual details, was extended to the end user through the service catalog at ServiceNow. And they were required to simply fill in certain standard data points of what their application instance was going to consist of. In this case, the fully qualified domain name, the service listener port, associating a profile if other than a standard HTTP. In this case, it was not simply a standard HTTP. Persistence of desire, and a health monitor as desired, and a load balance methodology. The pool members were identified, and the pool members were specified by the end user. In this case, it was under the assumption that the end user was creating a virtual service and they had already identified pool member instances themselves. So they had the IP addresses for pool members. However, it's going to dynamically fetch an IP address and reserve a free IP address for the VIP service. As you'll notice, that was not one of the identified parameters. And it was indicating a ServiceNow deployment. So if there was a time frame that it needed to start in order to conform with change management, it would have been specified. Otherwise, in this case, there were no change management constraints, so it could begin at the time of instantiating the request. So within the workflow sequence, it required the first step of reserving and fetching an IP address to assign to the VIP. And you'll see the record www was created, and it fetched the IP of 192.168.42.78. It'll perform pre-validation and generate the implementation configuration set for the virtual service and a post-validation. There's a pause for approval. So the requestor would have initiated the request, and for governance practices, the approval submission would have gone to the appropriate technology skill sets to validate that, okay, this is an authorized deployment sequence. In this case, it's showing the listing of the virtual service and pool for validation. And then the work order is submitted after the approval. And then finally, you have the implementation and post-validation. So you'll see in the implementation here, it created the pool, created the virtual service instance, assigned the IP that was retrieved from the DDI services. And then lastly, validating that the configuration construct was actually applied to the load balance platform. So as an example of highly repeatable workflow structures that you can use to deploy application instances, that would be one of them. The flexibility of customizing your workflow sequences is available through the Workflow Studio. And if I take a look at that one that we were looking at earlier called Zero Touch Provisioning of Application, let's take a look at this one instead. We'll see that the drag and drop visual palette, which I was describing, is represented here. And as I was saying, it's meant to be a highly intuitive, easy to use workflow generator. What we have is a library of existing services or tasks along the left. And you'll see that there's a large number Some consist of basic logic items. Some consist of individual service resource requirements. So for example, the DDI info blocks item, we have creating of a DNS record, A records, PTR, TXT, and so forth, which you can simply drag and drop into your design palette, connect them in the desired orientation, and then validate the workflow, and you have a published, repeatable workflow service instance. As this example depicts, there's an input form for gathering details related to the application that we're trying to deploy. It fetches and reserves IP, sends out a communicator for status updating regards to the service request. It would fetch a certificate instance because this particular application build is for an encrypted application service. So we're obtaining a digital certificate. Again, a communicator for notifications in regards to the status. Then creating of the virtual service. Again, a communicator, enabling of the security policy, and then closing out of the service ticket and final communicator notifications indicating that the request item has been fulfilled and completed. So last item, the App Vision application view, which is for dynamic discovery and visibility to application-centric views. So if we look at a sample application instance, which all of these application instances are discovered by way of the devices that are under management. The AppViewX platform is communicating with infrastructure devices via SSH or the API reference, and therefore has the ability to see the of your infrastructure. So here what we're seeing is an application instance called ecommerce-services.mybank.com. So we have the fully qualified domain name. We see that this service instance or the application instance lives in 3 locations. We have 1 location distributed through an F5 load balancer. The other 2 instances are guarded by firewall instances prior to having accessibility down to a load balance service instance. And we have multiple certificates that are associated with the VIPs or virtual service instances at each service endpoint. And you'll see the pool members associated with each service instance. Now, not only do we get the visual representation of where the application actually lives, but we have the state and status of the application components. So we'll see here that the green indicator illuminated at the load balance at the firewall gateway device, and we can view the individual details of this configuration item. So we'll see that there's a security policy definition that's allowing this particular traffic flow. It had been named allow to. We'll see that the hit count, the source address permission, destination address permission, application services. So if you have application groups or service definitions, we're seeing the entire configuration relative to the application instance. We can also perform troubleshooting directly from this particular location to where we can execute things like a trace route, a ping, or any other customized command set directly from this particular component. So in summary, we've been able to demonstrate how the AppViewX platform contributes towards the deployment maintenance of microservices within network infrastructure. I'd like to open up for any questions. Let's see, I think I've got one coming in here. Does the AppViewX platform maintain a directory of services as they are created and removed? Yes, that's the app vision component. So as applications are deployed, when the AppViewX platform has the ability to communicate with the platforms or network devices, it will dynamically discover the application instances. So even if you have not deployed the application instance through AppViewX, if the item is within the inventory of AppViewX, it will have a directory or discovery of the service. Really quickly, I will go back over to the AppViewX instance and just show you under device inventory where the managed devices are listed. So under that module, we have ADC, server, DNS, firewall, WAF, switch, router, proxy, cloud, HSM. What this is showing is for each relevant infrastructure category, the devices that AppViewX is communicating with. So it's being, with a valid communication session, it's able to discover all of the virtual servers, wide IPs, every configuration item that exists on that particular platform. Likewise with server platforms, all virtual hosts, web services that are offered, SSH key infrastructure, and the same would go for firewall, all security policy parameters. And for DNS services, if we're integrating with, say, an Infoblox or DEI management, it's able to identify and make reservations for all of the components that we had described in the visual workflow catalog. Any other questions? How do I assign ownership of microservices in AppViewX? That is going to be available through the role-based access control definitions. And let me quickly try to show you where that administration is. So under the account definitions, we have role and resource definitions. then we can leverage your existing IAM structure. So if you're utilizing, say, LDAP or even single sign-on like SAML solution, TACAX, we can integrate with those platforms to authenticate users. So the user is authenticated externally, and an attribute is returned to define what role they would be associated with. So let's say that you have in your organization existing LDAP categories of DevOps, NetOps, security ops. So as a member of one of those organizational units is authenticated and their attribute is returned, it would be mapped to the individual functions which can be performed by that organizational unit. So in the example here, we have DevOps, and each one of these, as I expand all of them, these radio check items are representations of all of the functions within each of the modules and submodules of AppViewX. So as it relates to, say, server certificate management, you could identify whether or not the individual role could make a reissue, a renew, a resubmit request as it relates to server certificates. And so when you enable those particular functions, that organizational unit and its members would have access to perform that function. The second item is resource. So role defines what functions a user can perform, and the resource definition assigns what items they can perform those functions on. So as I look under the access control, I'll have a complete breakdown of all of the resources within the AppViewX platform. So as it relates to, say, ADC, if there are application instances that I have, and let's just say, well, we looked at that ecom one earlier. So let's say that I want this particular organization to be able to manipulate, i.e. read, write, any of the service instances that are associated with ecom, then I can allocate that read write, add the regex expression into the filter, and that would permit that particular role of DevOps to be able to edit the objects associated. Now, there'll be VIPs, pool members. I could further refine that to just virtual servers, just pool members, whatever level of granularity that is necessary through this particular interface. Any other questions? Well, if that is all for today, I appreciate everyone showing up and taking the time. Look forward to sharing more information with the community. Anything that we wanted to wrap up with?
Thank you, Glenn, for the great session. And thank you all of you for joining us today. I hope you found the session insightful. We hope to see you again at our next webinar, the topic and date of which will be announced shortly. Once again, thank you all and have a good day. Thank you.